Today we're going to be making our review video for chapter 11.3. That's chapter 11, section 3. And as always, we start with the learning target. The learning target for today is to construct and interpret circle graphs. All right, so a definition of a circle graph is a type of statistical graph used to compare parts of a whole. The entire circle represents the whole body. So let's do one as an example. I think that's the clearest way to do it. Tornadoes, the table shows when tornadoes occurred in the United States from 1999 to 2001. Make a circle graph to determine a circle graph using this information. Well, if 15% of the tornadoes occurred January through March, that means that 15% of our circle has to show that area. So 0.15, that's 15% in decimal form, times 360 will give me the degrees or the amount of the circle that has to be used for that area. So that would be 54 degrees. That's equal to 54 degrees. The next section, which is 53%, so that's 0.53 times 360, tells me that 190.8 degrees is used for that portion of the circle. 21, so that's 0.21 times 360, and of course we're using 360 because that's the whole circle. 360 degrees makes up a whole circle. So 0.21 times 360 is 75.6 degrees. And the last one, 11%, is 0.11 times 360. 0.11 times 360 is 39.6 degrees. I'm going to add those all up to see if they come out to be 360, which would tell me I've got all of the parts accounted for. And as I check that on my calculator, it does come up to be 360 degrees. All right, so I'm going to now do a little quick sketch here of the circle. I'm going to start by dividing the circle up into kind of the 4 quadrants that would look like on an XY plane. And of course, we know that the dimension in that quadrant would be about 90 degrees. So I'm going to start with the first one, 54 degrees. It's a little bit less than 2/3 of that first quadrant. And that would be this area, which would of course represent 15% of the tornadoes. The next area, and I'm going to start right here, and I'm going to go another 190 degrees. So that's a little bit more than a straight line, so it's a little bit more than right here. It would be 10 degrees more than there. So let's go to about right there. And all of this region would represent the 53% of April to June. Okay, the last area is 75.6 degrees in my circle. So 75.6 degrees would be continuing on to about right there. So that would be my sketch for that area right there. That's 21% of the total. Again, 75.6 degrees measured with a protractor. And the last section, which is 40 degrees or 39.6, is this, and that represents 11% of my circle. So I'm going to be looking for a drawing that has it broken out somewhat like that, and here's what the book did. Okay, we can see that the 15% was just slightly more than 54 degrees. I'm sure if we took a protractor and measured that, we'd find it's more than 54 degrees. The 11%, which was just about 40 degrees, not quite, a little bit less. And then 21%, the 21% was about 75.6 degrees. And the last one, which is just over 110 or 190 degrees, would be the 53%. So I think our sketch matches that pretty well. Right. So the table shows when hurricanes or tropical storms occurred in the Atlantic Ocean during the hurricane season of 2002. Make a circle graph for this information. Well, the first thing I'm going to do is I'm going to say, all right, if this was 7%, so I'm going to go 0.07 times 360 to find out how many degrees that is. So I go to my calculator and I make that calculation, and I find out it is 25.2 degrees. The next area, 21%. So I'm going to go 0.21 times 360 is going to be 75.6 degrees. The next area, which is 64% of the circle, so 0.64 times 360 is going to be 230.4 degrees. And the last area, which is 8%, would be 0.08 times 360, and we would get it is 28.8 degrees. So again, a quick sketch. I'm going to divide it up into quadrants. All right, the first area I'm going to graph is this 230 degrees. Well, 230 degrees is about, there's 90, there's 180. All the way to here would be 270, and I only need 230, so I'm going to go about 40 degrees short of that. And I would say that this portion, all of this portion, is the 64%. 64%. All right, I'm going to do the probably the 21% or the 75.6 degrees. So this would get me on up to about 270, which would be about 40 degrees more. And then I've got 25 degrees beyond that. Say it's about right there. And that would be 75%, or I'm sorry, 75 degrees, or a total of 21%. All right, the next area would be, actually we're splitting, it's about 25% and 28%. So 25 and 28. This would be the 28, and this would be the 25%. So it's going to be a graph that looks something like that. Let's look and see what the book came up with in that area. All right, I'm sorry these are so blurry, but if we look closely, I think we can see that it is definitely not B, it is definitely not C, it is probably either A or D. As I look at A or D, I think it's going to come out to be A. Sorry, those are so blurry. I wish we could read the numbers a little more clearly to determine for sure it's A, but A, I think, is probably our best estimate, just looking at common shapes. Here's taking it all the way from scratch. We have average points per basketball game for the top 25 scorers. They tell me there's 25 players. So on this first range, I'm going to say, well, there's 6 out of 25 in that first range. In the next range, there's 12 out of 25. In the next range, there's 1. Let's do a different color here. Let's go 1 out of 25. In the next range, it looks to be that there's 4 out of 25. And the last range, probably 2 out of 25. So I'm going to write those fractions down. I've got 6 out of 25. I've got 12 out of 25. I've got 1 out of 25, 4 out of 25, and 2 out of 25. So I'm going to calculate the percentages there. If I take 6 divided by 25, I get 24%. If I take 12 divided by 25, I get 48%. If I take 1 divided by 25, I get about 4%. 4 divided by 25 is 16%. 2 divided by 25 is about 8%. Now, if I take each of those times 360 to calculate how many degrees of the circle there will be, 6 out of 25, or 0.24 times 360 is about 86.4 degrees. 48% times 360 is 172.8 degrees. 4%, or 0.04 times 360 is 14.4%. I'm sorry, 14.4 degrees. And 16, which is 0.16 times 360 is 57 57.6 degrees, and the last one, 8 degrees, or 8% times 360 is 28.8. Now a quick sketch over here, not spending, well, let's make a little better circle than that. All right, again, put in my quadrant lines just for some guidelines. The first one I'm going to draw is, I think this 86.4, it's just slightly less than a quadrant, slightly less than one quadrant. That would be our first area, and that represents 24%. The next area I'm going to draw is probably that 172.8. Again, just slightly less than 2 quadrants on this case. We'll be over here very close to that divider line, but this would represent 48% of my total. The next one, which would be 14.4 degrees, 14.4 degrees would represent just a tiny bit more than that. So I think this would be my 14.4%. Which ones am I missing? Well, I'm missing the 57.3 degrees and the 28 degrees. So this could be my 28 degrees, which is 8%. And the last area here, of course, is the 57 degrees or 16%. 16%. All right. Well, let's look at what the book came up with and see if we came up with something that looks basically the same. I think we did. I think it's very, very close to the same. The only difference, the book, of course, they used a protractor to draw theirs rather than estimating their angles. I'll make a circle graph using the information in the histogram below. So there's the histogram off to the side, and then we'll decide which one of these graphs looks the most. Well, it looks like there's 10 players that we're talking about. So in the first area, there's 4 out of 10. In the next area, there's 3 out of 10. In the next area, there are 2 out of 10. And the last area, there's 1 out of 10. So that first area is 40%. The next area is 30%. 30%. The next area is 20%. And the last area is 10%. So 40 plus 30 is 70, plus 20 is 90, plus 10 is 100%, so that checks out. I take 40 times 360, and as I multiply this together, I've got 40 times 360 will give me the portion of the circle there, 30 times 360, 20 times 360, and 10 times 360. As I start to look at these drawings over here, 40% for the people that score 0 to 7 points, 0 to 7. Looks like it would be this one right here, probably the best, maybe as much as that one. Next one, 30%, looks to be the purple ones. Probably the best estimate of the purple ones is either this one or this one. This one we'd already eliminated, so it's up here. And then we've got the 20% and the 10%. It does look to be answer A is probably our best graph estimate. Using the circle graph to describe the makeup of the average game scores of 25 top scoring basketball players, average points per game for the 25 scores. Well, as I look at this, there's 48% of the people score between 13.1 and 15. If I add that to this, that gives me almost 3/4 of the players, because I've got 24 plus 48 would be 72%. 72% is very close to 3/4, which is 75%. 3/4 of the players score between 11.1 and 15 points per game. 1/4 of the players score between 17.1 and 21 points. There's lots of other comparisons that could be made, but that's an example. The last graph, the last problem, it says check the circle graph or use the circle graph to determine if the following statements are true or false. More than 1/2 of the players had an average game scores between 0 and 15, so more than 1/2. So if I go 1/2, well, between 0 and 15, that would be those two areas. 30 plus 40% would be 70%. That is definitely 1/2. So that statement is true. That statement is true. And 10% had average scores greater than 23. Let's find the average that would be greater than 23. Greater than 23 is 24 to 31, and that is 10%. So that statement is also true. So both of these statements are true. Thank you.